And once again, I'd like to welcome everyone to the LA Birders webinar for tonight. We are really pleased to have Dr. Julian Garcia Walther with us. And to introduce Dr. Walther, we have Tori Fay, our program chair with LA Birders. Tori.
Great, thanks, Ron. We're delighted to welcome Dr. Julian Garcia Walther as today's speaker, bringing deep expertise in shorebird ecology, coastal conservation, and the growing impacts of climate change on bird habitats. Julian is originally from Mexico and has spent the last decade immersed in field biology and conservation, with a particular focus on shorebirds and marine birds along the Pacific Flyway. He recently completed his PhD in environmental conservation at the University of Massachusetts Amherst, where his research focused on how environmental change and sea level rise impact the survival, habitat use, and movement ecology of migratory waterbirds. A major part of his work involves the MODIS Wildlife Tracking System, an international network of radio telemetry stations that allows scientists to track the movement of small migratory birds in incredible detail. Julian has led the expansion of MODIS stations across northwestern Mexico to track the red knot, which depends on Mexico's coastal wetlands during its migrations. These high-resolution data help reveal how birds use specific habitats and how rising seas may be shrinking or shifting the spaces they rely on. Julian's recent research and efforts at Pro Natura Noroeste model how sea level rise may inundate large portions of critical wetland habitat in northwest Mexico, threatening the availability and quality of roosting and foraging areas for a wide variety of coastal waterbirds. His work helps fill in a major knowledge gap in the climate and conservation conversation. While sea level rise is one of the most certain outcomes of climate change, its specific impacts on bird habitats in this region remain among the least studied. Today, Julian will guide us through what the future may hold for waterbirds in Northwest Mexico and how their incredible journeys are being shaped not just by where they go, by what's changing beneath their feet. So please join me in welcoming Dr. Julian Garcia Walther.
Great, thanks.
Thank you, Tori. I'm definitely going to steal this introduction because it sounds much better than what I typically do. And
Thank you.
yeah, and I will refrain from doing bird jokes because I cannot surpass your jokes. So I'm gonna go ahead and share my screen, and you guys can tell me whether you see it or what do you see. Let's see.
So far, we see your Zoom screen. Oh,
And swap.
and
How about now?
and we see the screen. Oh, there we go. You have a full presentation now.
Perfect. So, thank you again for the invitation. We scheduled this invitation like 1 year ago, so it was a long time, and I'm happy that it's finally happening, and I'm very happy to be here with all of you to tell you about what I have found in my dissertation related to the effects of sea level rise on water birds in Northwest Mexico. So. I was going to tell you a bit about me, but Tori just said everything. And I just wanted to add that I did my PhD at Massachusetts, but I actually spent most of my time in Northwest Mexico doing field work, and it was fantastic. Um, I collaborated with this NGO called Pro Natura Noroeste. I right now work for them, and it has been a fantastic journey. I just wanted to show all the region in Northwest Mexico where we are going to be talking about and where Pro Natura works, and also share with you that I'm based on the city of Ensenada, right here. Uh, I hope you can all see my cursor of the mouse. But Ensenada has a very nice connection to the US because it's just 1 hour from the border from San Diego on the south. So I guess I'm just trying to entice you to come and visit because we have great craft beer, great food, great wine in the wine region, and also really good birding. So there's four good reasons to come and visit. Um, and Ensenada up here is embedded in what's we call the Baja California Peninsula. That's right, we don't call it Baja. And this peninsula is a fantastic place. I love it, and it has a very nice location on my heart because I spent the last decade doing conservation and traveling through this peninsula. It's one of the places where you can be there and at any given point of the peninsula, you won't see any person in many kilometers, which makes it very remote, very pristine, and perfect for field conservation. Now, the thing with peninsulas is that they are surrounded by water on all of the coastline, and this means that the coastal areas can be very vulnerable to sea level rise. If we look at the geological history of sea level rise, not only on the peninsula but on the whole hemisphere, we see that there has been changes. On the past 2,000 years, you can see the blue line. These changes kind of seem homogeneous, but that's only because they have been dwarfed with what has been happening on the last 30 years. You can see a very rapid spike on what the instrumental record is showing as an acceleration of sea level rise. So let's talk about what is driving sea level rise. So sea level rise is a consequence of climate change. And if we had to boil it down to two of the major drivers, we would see that things like thermal expansion, that is, the water of this planet heating up, is causing the molecules to expand. If this is compound with the loss of ice caused by this warming of the water, we get that, yes, all around the world, we are seeing a rapid increase in global sea level rise. Now, it's difficult to see sea level rise. The changes seem very subtle to our eyes, but it's definitely happening. And the thing with sea level rise is that we know that it's happening, but we do not know very well how much sea level rise to expect on the future. There's a lot of uncertainty. Take, for example, this graph here in which you are seeing different scenarios for sea level rise on the US. You can compare the more conservative with the more extreme scenario, and you see that there's 2 meters of difference. That's a lot of uncertainty. And so the good news for you guys living across the border in what we term the global north is that you guys have really cool tools and data to assess very precisely which areas are being vulnerable to sea level rise. This is an example from Boston, but you can have it from LA or San Francisco or anywhere on the US. In comparison, in other areas of the world, well, we are lacking, for example, in the global south, we are lacking the tools, the frameworks, and the modeling experience to come up with these predictions. And we thus know very little about what sea level rise may behold to coastal ecosystems. This map here is showing areas in green and bluish pixels, those areas that are holding the most low-lying areas and ecosystems. So you can see that the global south shares a big proportion of these ecosystems, such as mudflats and mangroves. And this has shaped what I did in my dissertation because I asked myself, what will the future of this low-lying ecosystem would be? Because I'm a shorebird biologist, I was wondering how are these groups of birds going to respond to these changes on their habitats? Now, this is very relevant for Northwest Mexico because we have a lot of low-lying areas, and many of these areas are coastal wetlands, which are incredibly important for migratory birds. 16 coastal wetlands alone host about 1.5 million waterbirds of 70 species. And many of these species, the trends and the science, they are showing that they're in steep decline. Now, it helps to understand how they're going to be affected. If we change our human-centric perspective, it put ourselves into their perspective. Let's make a hypothetical situation where we take, maybe a scenario from 2050, where we could expect something around 30 centimeters of water increase. And you cannot see it, but I'm a pretty tall guy. And, this would mean that the water would reach maybe below my knees. But if we put in the perspective of the birds, 30 centimeters increase means that their whole habitat is going to be deeply transformed in just a few decades. So then let's talk about what waterbirds are looking for in Northwest Mexico. And before we do that, I'm just going to make a pause and let you know that when I am talking about waterbirds, I'm actually referring to birds that can wade but cannot swim. So we're not going to be talking about brands or any kind of duck, for example. And many birds use Northwest Mexico to breed. We have about 20 species of shorebirds and many other water birds. You can guess this is one of the most iconic birds that we have on our beaches. It's the snowy plover. But not all birds come here to breed. We also have birds that are long-distance migrants coming from Alaska, from Canada, that come to Mexico looking for these really special places where they can spend the winter and where they can find these extensive mud flats to feed during many hours of the day. So this is a picture of Guerrero Negro, and you can see at least 25 species of different shorebirds and waterbirds, which is really amazing. But regardless whether you're breeding or coming to forage for the winter, all birds need to rest. And they do so at what we call the roost of the birds, right? And I don't know about you, but when I finish work, I like to go and take a nap. And it's nice when, take a nap near the kitchen because I tend to wake up pretty hungry. And so as I do, birds like to roost near their foraging areas. But the foraging areas are decreasing, so as their foraging grounds. So we needed data to test hypotheses and to learn more about how these phases and the life cycle of birds would be affected. So over this presentation, I'm going to be telling you how we came up with ways to come up with this data that did not exist and how we improvised in many cases. We're going to be talking about bird surveys in different parts of Mexico, about all my travels trying to catch these birds, to attach transmitters and learn about their habitat use, and about the fact that I'm not an expert in everything, and I had to ask a lot of help to many people to teach me how to model sea level rise in Mexico. So, just in a nutshell, we're going to be talking about 4 stories. And the first one has to do with like a big picture of what's going to happen to wetlands and their birds in Northwest Mexico. Then we're going to go to Ensenada, my city, to talk about breeding birds and their risk of tidal flooding of nests. And finally, we're going to end up in Guerrero Negro to talk about 2 important aspects. First of all, how are the foraging areas of these birds changing in space and time due to sea level rise? And the last story, which is my favorite, how are these birds are going to adapt to find a rest spot as, the environment is changing with climate change. So buckle up, and I hope you like this presentation. And here we go. By the way, please do stop me if I'm talking too fast because I cannot hear myself.
Will do.
All right, so let's start with the whole Northwest Mexico and what the future awaits to the coastal wetlands of these areas. This was my first chapter of my dissertation, and I really didn't have a clue what I was going to do for the whole dissertation. I thought that exploring what we call the Mexican National Climate Change Strategy was a good start. And so I read it all from beginning to end. And to my surprise, the word sea level rise was not there. It was kind of surprising because when you look at Northwest Mexico and make a quick analysis about the land that is less than 10 meters in elevation, well, that's a lot of it. So there's a lot of vulnerability. And this led me to my first question of how vulnerable are these coastal wetlands in Mexico to sea level rise? So I knew that I needed data related to where are these wetlands and how much sea level rise we can expect in Mexico. And because I was studying in the US, I thought the data must be there. The US has a lot of this data. But when I went to Mexico, there was no data at all. So I painstakingly had to take satellite images and start finding and digitizing each of these coastal wetlands, about 300 of them. And luckily, I did find a model of sea level rise for the year 2050. And I was able to combine these 2 data sources to pinpoint more or less how much wetland extension would be affected by sea level rise. You can clearly see here the result. About half of the wetland extent that we have in Mexico can be at risk of permanent inundation in just 25 years more. That's a lot. And this immediately gave me my second questions to try to understand what are the implications for the water birds that we are trying to conserve here in Mexico. And I've always wanted to work with a species that was threatened and was rare, so I naively chose the red knot as an umbrella species. So let's talk about red knots. Um, I'm sure you're aware, the red knots that we have here is the subspecies Rosellari, and it's a bird that's slightly different to the one on the Atlantic, Rufa, which is the other subspecies, because this bird, I have a decoy here, it breeds in Russia and in Alaska, and then it migrates down the Pacific Flyway into the coast of Mexico, where it will spend about 9 months. And unfortunately, it doesn't look like this anymore. It looks more like this, a little bit more drape and less interesting, but I still like it a lot. Now, we didn't know a lot about this bird because they're kind of elusive and they inhabit remote areas in Mexico. So we use satellite transmitters, Motus transmitters, we use wetland surveys at different wetlands to try to find more about where they were. And then we also use eBird data to inform us on those locations. And once we had all of these locations in the whole northwest of Mexico, we were able to use the location to extract data that informed us about what makes a red knot happy. So we use the location to extract what elevations they were using, what vegetation, how far from a wetland, and we came up with a model. This model, we call it the current species distribution of the red knot. And this map that you see here, what it's showing us is the greener the pixels that you see here, the more suitable the habitat is for these birds, for these red knots. So if it's gray, it means that it's completely unsuitable and that you should not find it on the gray areas. Okay? But we were interested on knowing where could we find the red knot under a future sea level rise scenario. So we combined this map and rerun the model using the sea level rise scenario that we had for 2050. And you'll see that the map looks a little bit different. You'll see two things. First of all, some areas like this one in the Colorado River Delta that used to have pixeled colors are no longer colored. And this is because presumably the model tells us that these areas are going to be inundated and no longer available for red knots. The second thing is that if you look at the pixels, they change in coloration, tending to be more grayer than greener. So they have lost suitability. So this is a very qualitative way of seeing how the habitat may change in the future. But let's look at a more quantitative way. This graph here is going to show you the 10 most important wetlands that we have on the country for red knots. You can see their locations on this little map here. And what I'm going to show you is what we call the highly suitable habitat index, which is something that I invented that kind of summarizes how suitable a wetland can be for red knots. All right. So for these 10 wetlands, this is the highly suitable habitat index that we should expect for the red knots, and it changes depending on the wetland. But the interesting part comes when we compare how this index will look on the future. So when we do that, we see that by the year 2050, 8 of those important sites have decreasing suitability by about 18%, and 2 of them are no longer having highly suitable habitat, which means that, they are no longer providing this important habitat for red knots on the future. Now, this doesn't paint a good picture for the red knots or for other birds that use their habitat similarly to them. And I have just told you that by the year 2050, these red knots will have likely lost about half of their habitat to inundation, and that the habitat that remains will be, well, of a lower quality. Again, this is a brushstroke of what's happening on the coastal wetlands of Northwest Mexico, but sea level rise, it's a little bit more complicated than that. So let's explore and detangle these nuance, thinking about the specific parts of the life cycle of birds individually. And Now we're gonna go to the second story, and we're gonna be talking about breeding water birds and the increasing risk of tidal flooding. So for this story, I'm gonna invite you to my home, to Ensenada, and the city of Ensenada is here, and it's embedded on what we call the Todos Santos Bay, and it also has an estuary that is called Estero Punta Banda. Okay? And the bay has a beach which is sandy and it's about 20 kilometers long. And it's also the home of two of the most threatened beach nesting birds. I guess by now you probably guess which ones are those. There are the snowy plover and the leastern. And I think one thing that is kind of cool of these two birds is that they both nest on the sand, but they also have very cute cheeks. Now, what I'm going to show you now is one of the areas where these two birds put their nest in large densities, and it's on the sandbar spit of the Estero Punta Banda, so this region here. The circles are Leastern nests, and the triangles are snowy plover nests. And I want to show you what are some of the reasons or what some of the fates of snowy plovers and Leasterns in a given year. So typically in a year, we will have around 28% of nest success and about 54% of nest loss due to predation, abandonment, or other reasons. Now, I want to focus on this 18%, which is the rest of the birds that are lost to tidal flooding, because through this research, I want to show you the nest flooding is exacerbated by things like sea level rise and extreme weather events, something that is becoming even more common. Take, for example, this picture, which is not from Ensenada, it's, I think, from California. And I just want to show you that if you have waves, these waves, if they get stronger with storms, they cause coastal erosion. And what happens is that the habitat that birds use to breed or to just roost keeps getting narrower and narrower, and this generates more vulnerability for nest flooding. So to this respect, something that has been sort of like a gap of knowledge or has not very well studied is that how important the morphology of the beach is for breeding birds. So take, for example, this diagram that actually comes from real data from our beach in Ensenada. And I tell you it comes from real data because we go out there with this GPS to measure what's the profile and the shape of this beach, right? This is what we call a berm. It's like a platform that is ample and provides a lot of space for birds to put their nest and to nest safely without being inundated by the high tide. Okay? And this is how a typical summer beach looks like. Now compare the summer beach to a typical winter beach. Something really interesting is happening here. The berm that we saw previously, it's gone. And it's gone because typically in winter, you see these on LA too, you have stronger storms and stronger waves. And these waves kind of like act as an excavator, bringing all of this sand into deeper depths of the water. And the beach tends to be a little bit more narrow. So we lose the berm. Now, here's the catch. When we have normal climatic conditions during the spring and summer, this sand comes back and the berm is rebuilt so that birds can nest. So our hypothesis is that right now with climate change, wave action is leading to more erosion, and this is actually causing the decrease of survival of nets. But if you're a bird that decides to nest on berms, you could buffer the effects of tidal flooding. So I would like to show you how we tested this. The study area of the story happens here on the sandy speed bar. And we have these lines here, which are topographical profiles that were measured with these very precise GPS by the Mordix group, one of our partners, every single month. Then we have two of our other partners, Protesteros and Pajarando y Conservando, who went here to the colony of terns and to the nest of snowy plovers to every 2 days during the week to see whether they hatch or whether they were lost to flooding or other, you know, situation. And then there was me trying to crunch all the numbers and came up with this story. Yeah, so I'm gonna walk you through what's these three-part graphs and show you how wave action actually influences beach morphology and how that affects birds. This first graph here shows you a measure of the ENSO index. The ENSO is the El Niño Southern Oscillation. In a nutshell, if you have these peaks here that are above this middle line, it means that you had a very strong El Niño year and that you had strong storms and coincidentally, well, strong waves because the second graph here is showing you the wave power. We had instruments in the water that could measure the waves, and so when you find these peaks here, it means that you have strong waves. And this time series goes all the way from 1984 to 2021. All right. The last and most important graphs is showing us the shape of the beach. If you have these lines, which represent topographical profiles like I show you on the map, and if they're above of this dashed line, it means that the beach has become wider. It has accreted sand, it has gained sand, okay? If it's below this dashed line, it means that the beach has become narrower and that the beach has lost sand. So to tease up this apart, let's focus on these three periods of time, and you'll see that during 2010, we had a strong El Niño event with strong waves, and we lost a lot of beach, right? But as we have expected, the beach recovered after, the spring and summer. But this did not happen in 2016 and 19. We lost a lot of beach and we did not recover it. And so this relationship shows us that beach morphology can actually affect nesting habitat. Let's tease these apart even further. And let's focus on the study area on this topographical profile number 3, where we have some nests of least terns and snowy plovers. So here we have the profiles of the beach on June from all of these years, from 2018 to 2022. We also have here what is the mean high tide, mean water line, okay? And let's detangle what this profile is telling us. On June 2019, you can see this very steep profile that coincides with a strong El Niño year. And it's so steep that the birds didn't even have the chance to put their nest because there was no space. Now let's compare it with a year, 2022, when there was a very nice berm. You can see the platform here. The circles represent the nests. And if a bird would have put their nest on the berm, it most likely would have been successful. But if you put it too close to the water line here, most likely you lose it, right? If you do all this math numerically, you see that by being a bird that puts its nest over a berm, you have about 76% more chances, 78% more chances of having a successful nest compared that if you wouldn't have put it on other place that was not a berm. Okay, so huge difference. And this tells us that actually berms are really important and they're important to buffer the effect of tidal flooding that it's going to become likely more extreme on the future. But beaches, they cannot always rebuild the berms, especially after extreme climatic events. So as sea level rise is likely to exacerbate this tidal flooding, the fate of birds may lie on them being more flexible to be able to find the berms and nest over them. So to me, this was a really cool paper and a really cool research that came spontaneously. But let's leave Ensenada and let's switch gears and talk about foraging water birds and what the fate of their feeding grounds may be at Laguna Guerrero Negro. So here's the city of Ensenada. And during my field work, I would have to drive about 7 or 8 hours to Guerrero Negro, which is here. And it is the biggest coastal wetland of the whole country. It's enormous. And it's also a very important place for migratory birds. Many birds of different species come from Russia, from Alaska, from Canada, and the US to this place to spend the winter. The place in a satellite image looks like this. It has one smaller lagoon called Laguna Guerrero Negro, which is going to be the focus of this story. And it has another bigger one, a lot bigger one, Laguna Ojo de Liebre. And I tell you that it's super important for birds because at any given time during the winter, you could see about 250,000 birds on average of 77 species. So a fantastic place to go birding during the winter. Plus, if you go in the winter, after December, you can see some of the biggest, how do you call it? Where the whales are born, and it's a fantastic experience. So two good reasons to go to Guerrero Negro. So, because of this importance, there's an urgent need to understand how sea level rise will change the habitat for waterbirds. Because right now, the dynamics work very well. During low tide, as you expect, you have a lot of waterbirds foraging on the shallow areas. And then as the tide comes up, they move to their high tide roost. They will just rest and recover and wait until the tide goes down to go again to forage. But what can we expect in the future? Well, this dynamic might change a little because we expected the hydro period will lengthen. So with hydro period, I refer to how long does a mudflat remains underwater with the tide, right? If we add more water, you might have a longer hydro period. If you see it from the perspective of a bird, these mudflats, they represent sort of like a restaurant for them. And it helps to use an analogy of using the mudflat to try to understand how long is this restaurant open for this bird each day. Okay? So this way of seeing the mudflats and their importance for birds, like really took me on a rabbit hole because I always thought that sea level rise was a question about space, about how much space will a bird lose as sea levels are increasing, right? But there's often an overlooked dimension of sea level rise that we fail to see, and that is the dimension of time. Because as the water increases, the availability of these mudflats will change. So the time that these restaurants are available will likely change. And I wanted to explore these two questions. So again, all of this research is about data and we lack data. So I spent a lot of time trying to get data on how the birds were using the habitat. And this was perhaps one of the most frustrating, but one of my favorite parts of the research. Because to get the data, you needed to catch the birds. And to catch the birds, you needed to be very observant and become a naturalist because you need to identify where these birds are roosting. So a lot of observation, and once you find those spaces, you can try to catch them. There's this thing here, which is a box with a net that will be shot into the birds. You need to try to predict where these birds will stand the next day based on your observations. And that's where these decoys also come in handy. But often the birds, honestly, they will outsmart you and they will not want to go into the capture area. And you need to do some herding. I don't know if you noticed, but that's me trying to herd the birds into the trap. Doesn't always work, but sometimes you get desperate to just come up with some improvisation. Most of the times you fail and you just go the next day and try again. It's frustrating, but sometimes when the planets and the mood of the birds align, you manage to capture the birds. And then you have the chance to put these transmitters that allow you to track the bird, and they store the locations of the birds once you let them go. But tagging the bird is just half the job done because the way these transmitters work, you need to go with a tiny antenna to find the bird again and download all the data that has been accumulating inside of this transmitter. And this place is huge. So we went looking for these birds with a car and the antenna. We didn't find them. We went with a boat and the antenna. We didn't find them. So in a way, this gave me my last chance and the perfect excuse to pursue one of the hobbies that I wanted to always pursue. And I learned to fly. So took some classes, bought myself a paramotor, and like stick myself a big fan on the back and bought myself a parachute and flew through the whole complex with this antenna tied with gray tape on my leg. And I actually found the birds. And we were able to reproduce their movements once we downloaded the data. And you can see these here in the animations. My advisor was not very happy, but he was happy I got the data. Now, um, that's just the bird data. I still had to figure out a way to model sea level rise in this area where there was no data. And I'm a biologist, not a physical postal scientist. So I partnered up with some other collaborators. We went to the lagoon and used this very fancy GPS to measure the shallow areas of the lagoon. We went on a boat with an even fancier GPS to map the depths of the lagoon, put these acoustic Doppler profilers that help you characterize the currents of the lagoon, and combine all of these data with wind and wave information from remotely sensed data. At the end, the result of all of this was that we came up with these models for the future that would try to predict how much inundation we would expect. Okay? That's as simple as I can put it. And what did we find when we combined this information? Well, let's start with the classic question that had to do with space. How much foraging habitat will red nose lose on the future? So from the movement data, we were able to classify the movement based on the behavior of the bird. And so you can see here that the yellow spots here indicate areas where the bird was feeding. And this allowed us to really identify like the favorite restaurants of the birds, which you can see in these conglomerations of yellow patches. Now, check out this. This is a satellite image from the lowest tide in 2022. And you can see that the restaurants that redknots love, they coincide perfectly with the mudfloods that are exposed during low tide. So the question now is, how are these core foraging areas going to change on the future as we have more inundation? So on the lowest tide of the end of the century, the restaurants that redknots love will look something like this. You can see that many of the places they used to frequent, they are gone. They're inundated permanently. And about 43% of the foraging area is lost. Just imagine losing all of those in and outs and restaurants that you tend to go and they are no longer there. Doesn't feel good. So we were able to also take that movement data and translate it in what we call the daily activity budgets. Basically, we're able to measure the time they do each of these behaviors: roosting, foraging, and moving. And on average, redknots eat for about 13 hours a day. And this is relevant because uh, we were gonna use this data to come up with the answer of the second question: time. How much foraging time will the waterbird community lose on the future? Okay, so to answer that answer, I need to tell you two more things that I did. Because on an environment where fluctuating water depths change very rapidly with the tides, well, the size of your legs actually matters a lot. It's not the same being a small red knot compared to, let's say, a marble godwit or a different kind of egret that has very long legs, right? So at the Laguna Guerrero Negro Lagoon, there's this area that we call Las Cruces where we do a lot of our work. And at this point that you see this circle here, we did two things. First of all, we did bird surveys where we counted birds and classified them on small, medium, and large based on the water depth that they could tolerate before they would fly away. Then the second thing is that we installed these devices that are called water loggers that can tell you how much water you have at the mudflat at any given time every 5 minutes, right? So we use these things to try to understand how much time redknots and other small birds use to forage in these particular mudflats. And remember, redknots and small birds, on average, they have to forage for 13 hours. And this mudflat, the waterlogger, what it told us is that at these peaks here, you can see reflected, the rise and ebbing of the tides. But what's interesting is these gaps here because these are telling us the time periods of the day where these restaurants are available for the red knots, so the dry periods. So in this spot where we installed the waterloggers, this red knot was able to feed for 12 hours a day only. This means that it still needs to go elsewhere to fulfill its daily quota. So how would this mudflat with this dynamic look in the future? In the year 2030, we expect about 8 centimeters of water increase due to sea level rise. And from 12 hours that this restaurant is open, we go down to 8.4 hours. 10 years later, we go down to 1.6 hours. 10 more years by 2050, this restaurant is closed. It's submerged and not available for red knots and other small birds, which is kind of sad. I mean, it's a prediction, but all these predictions and these patterns are summarized with this line here, where small birds will lose access to these mudflat by the year 2050. But we were also able to do these for medium and large waterbirds, and we saw that while they too lose access to the mudflats, they do so at a later stage. Now, these dynamics and these patterns that we see here only apply to this spot at Las Cruces where we had the water logger. But remember I told you I went with a boat around the whole lagoon during high tide, mapping the depth of the lagoon. We had the bathymetry, and that meant that we could extrapolate the patterns that we see here for small, medium, large birds to the rest of the lagoon. So these patterns here will apply to other places that have the similar coloration to the size of the bird. For example, this area here will not be available for small birds by the year 2050. So this is kind of heartbreaking because despite of Guerrero Negro being a haven for birds and one of the best conserved wetlands in the country, sea level rise could signal the collapse of the waterbird community, with birds suffering not only the loss of foraging time, even before permanent inundation occurs. And just as a summary of what we found that redknots lose about half of their foraging grounds by the end of the century. The entire community will lose access to some mudflats by 2060. And especially small birds, they will lose foraging time earlier and faster than larger birds. So they're a lot more vulnerable. All right, bear with me because this is the last story and this is my favorite story because of the way that we came up with this research. It was quite improvised. So we're going to be talking about roosting waterbirds and their potential to adapt to rising sea levels. And we're going to stay within Guerrero Negro. And if you see this image, this is the Laguna Guerrero Negro Lagoon. And we're going to focus on this little square here at Las Cruces, where we had installed previously the waterlogger. You can see here 4 types of habitat going from desert to marshes to an intertidal bar that I will tell you more about it, and the mudflats. Okay? Here's the intertidal bar, which is kind of like just slightly higher in elevation habitat made out of sand, where birds really like to roost because it typically doesn't get inundated unless it's a spring tide. And so it's a nice roost. And quality roost sites are very difficult to find these days for these birds, and they're decreasing in numbers. And this is because they need to fulfill different criteria. If you're a bird that is resting, you want to be on a site that has low predation and out of disturbance, right? You don't want to be waking up. You want to be close to your foraging grounds because when you wake up, you're hungry. And it needs to be big and reliable because you want to rest where your friends are resting so that they can remain vigilant for predators. And these roosts, furthermore, are being threatened by sea level rise, especially during spring tides when the Earth, the Moon, and the Sun align, causing really unusual inundation. Because spring tides means sea level rise, and spring tides means higher and higher spring tides each month. Here's a picture of the desert in one of these spring tides where the water is reaching almost to the road, something that we didn't used to see um, very often. Now, to me, the good news is that we can use these spring tides sort of like a proxy to understand how birds are finding their roost when inundation is highest and when the locations that they typically like to roost are not available. And here's where the nice thing happened. Lots of failed capture attempts actually led to some very nice and unusual observations. This is a good thing about failing, that other things come as a surprise. And what I'm going to show you now is a video. And this video, it's a time lapse of the tide coming up. We were preparing to capture birds, and you'll see these, patches of dead seagrass just floating around. And I'd like you to focus your attention on these arrows because these arrows are pointing at some of the patches that are floating. I'm just going to fast forward here. So you see that these patches are actually carrying birds. And these birds are just being transported like if they were in a boat on a cruise ship, totally oblivious that they are being moved through the whole inundated marshland. And I thought that was just fantastic because I've never seen something like that. Just look at the birds. There's a lot of them. And we didn't plan for these. It was just one of those naturalistic observations. Uh, and I thought it deserved more, research to try to understand what was happening. So I'm going to tell you how these rafts are formed and how important they could be for these water birds. This is a close-up of one of these rafts where you can see some red notes, some willets, and other birds. And I'm going to tell you how the life cycle of what we call rafts is happening, at least how we think it's happening. And it all starts during the neap tides, where there's a lot of seagrass, and this seagrass gets detached from the bottom of the sea with the effect of the waves and the wind, and accumulates itself just on the mudflat near the intertidal bar. During the first spring tide, water rises unusually, and all of this rack that is still fresh starts floating and gets distributed into the marshland. When the neap tide comes, the water levels go down, and this rack starts getting dried, and it clumps together, forming what we know as the raft. And as the second spring tide comes, it starts floating. And birds start using it because they don't have a lot of option of where to roost. And we believe that these rafts serve as an ephemeral roost site for these water birds for this period of time of great inundation. Now, how important can they be for these birds? Over 4 spring tides, we counted about 26 rafts, although there were a lot more. They differ on their sizes from being very small and holding one bird to holding hundreds of birds. On average, these rafts could be holding up to almost 3,000 birds of 25 species. Now, most of the rafts were using for roosting, but we did see some feeding behaviors, which was kind of interesting. Um, and let me tell you numerically how these rafts are important for the water birds. During the high tide, the spring tide, the rafts are the only habitat that is available for roosting. And you can see here this at any given point of time during the spring tide, you could see about 60 birds per square meter on a raft. So that's a lot of birds are come together for space on the boat. And comparatively, the marsh, the mud flats, and the intertidal bar are not being used because they are inundated. If you talk about species richness, the rafts documented the whole community at them compared, to other habitats when they're available. And this tells us that during the spring tides, a few hundred square meters of rafts can be as important as the thousands of hectares of mudflats and marshes that are unavailable. Now, this led me to think, okay, what is going to happen to the roost sites that these birds are currently using? And so I used the movement data to first identify where these birds were roosting, which you can see in purple here. There aren't many places where they roost during high tide. And again, the question is, how are these roost sites going to look on the future? So by the year 2100, during the highest tide, these roost sites are gone. They're just inundated. So it tells me that, you know, these these strategies that we are seeing here might become even more relevant. But that's where the good news comes, because we are taking inspirations on birds to address sea level rise, and we're trying to mimic, birds' own nature-based strategies by creating artificial roosts. This is just one of the prototypes. And we are trying to test how useful they could be to be used in areas where there's a lot of disturbance or where you're losing, for example, roost sites. So I'm going to show you another time lapse with a camera trap of one of our prototypes of these rafts, and just to show you that some birds do use them, although we do still need to do some work to improve these. This just was an experimental approach. But we do see that artificial rafts can provide alternative roosting habitat during extreme inundation events. Now, just as a summary of this last story, seagrass rafts, they serve as an ephemeral roosting habitat during the spring tides, and they are used by entire waterbird community, and they host more birds than any other habitat during these periods of inundation. So yes, they're pretty important and actually very cool. Now, this is the end of my talk, but I didn't want to leave before giving you some conclusions that I think they're relevant. And so here goes some of the conclusions. Um, I just want to reflect on all the struggles I had over the past years to try to figure out what sea level rise is going to cause to the future, to the habitat of these birds. And it was a big struggle. But I also want to tell you that it can be done, and we can and we should begin addressing sea level rise in the global south. Because if we do, we can start figuring out what's going to happen to other places that are also important to waterbirds, such as, for example, Rio de la Plata estuary or the Amazon basin. Um, I have shown you that sea level rise has the potential to affect every aspect of the waterbird life cycle, from the breeding to the foraging and the roosting aspects. It can cause habitat loss across Mexico, both at regional and local scale, and it can reduce the time birds have to feed on their intertidal areas. As a global phenomenon, sea level rise may act together and synergistically across the whole range of a species, and this is why I think sea level rise, well, we don't see it like that. It maybe should be considered as an existential threat to waterbirds. Um, And to me, this signals the necessity to, at least in Latin America, to start planning now for the future by doing things like securing enough accommodation space of key ecosystems such as marshes so that they can adapt to sea level rise. We need to include sea level rise into, for example, our national climate change strategies. And this can only be done if we collaborate with other disciplines because, as I learned, we are not experts on everything. And to me, this research is a very clear clarion call for urgent action. So with that, I would like to thank you for your time. It's been a pleasure to speak to all of you. And I didn't have time to prepare this last slide, but at Pronatura, my colleagues and I feel that we do amazing work. On behalf of one of my fellow colleagues that does environmental education, if you'd like to donate, I have left you a link in here, and anything, sorry, is good. We typically take kids to the beach to teach them about snowy plover conservation. We give stipends to students to help out and to help on their careers to become biologists, for example. We work with shorebirds at Golfo de Santa Clara, which I didn't tell you about today, to protect red knots and other species. So uh, yeah, it's just an invitation, and I'll leave it there for a few seconds. Thank you.
And thank you
Wonderful.
very much, Julian. That was wonderful. I think everyone really enjoyed it. Um, when we finish off here, if you can send the donation information, we'll add it on to the webinar information on our website.
Good.
Mhm.
So, um, thank you again. That was wonderful. If anyone has any questions for Julian, please put them in the Q&A section down at the bottom of your screen. That kind of helps us keep track of all the questions, of any questions that come in. We appreciate that. And with that, I had a question for you. I know there's no easy answer for this, but as inundation occurs, there's a loss of breeding and mudflats breeding and foraging habitat. Um, and I take it there's not an equal amount of habitat created by this inundation, but is there habitat created or not really speak of?
It really depends on the, reality of each area. If you
Right,
look at cities that are heavily urbanized, where you have a lot of coastal development, inundation is just gonna squish, the intertidal areas between the urbanization and the water. That's what we call coastal squeeze. And this is why I call upon planning and reserving space for those marshes and those intertidal mudflats to just start shifting towards areas that are higher in elevation. The ecosystem, if you let them, they will do that, and it's amazing. And yeah, so in short, the ecosystem can respond to these changes on sea level rise. And I mean, I didn't mention it, but because I didn't have the best data, our models do not incorporate these dynamic responses of the ecosystem. So we
right,
should consider them a worst case scenario, if you will.
right.
Mhm.
Yeah, interesting.
Can I ask a question? So, Julian, my question was going back to the breeding, the sandberms and the importance for breeding. I know you talked about ENSO and how that impacts the sort of the depth and the size of the berms. Everything that I've read recently says that we are our cycling of ENSO is increasing. It used to be every 4 to 7 years, and it now seems like we're almost, going straight from an El Nino into a La Nina and back again. And I'm wondering if you know of any research or you have any thoughts about how that's likely to impact the breeding of these birds.
Yeah, yeah, I think when you think about, for example, snowy plovers and least terns, they rely on on predictability, right? And it's interesting to think about how they're choosing their nest for the next year. Is it Are they choosing their nest based on whether they were successful on a given year and they will choose to nest there? Or are they seeing what's happening when they arrive and they're scouting whether there's a berm or not? I don't have an answer for that, but I do know that, for example, Listerns in some places, they tend to really be very side faithful, and they will nest like 1 meter from the place where they had put their nest before. And to me, that's a bad thing for them
Yeah,
because they are setting themselves into an ecological trap. If the environment is changing so unpredictable, they probably should take cues of what's happening that given year instead of just relying on where it has been good.
yeah, yeah,
So that's why I think I mentioned that it helps to be very flexible on these unpredictable changing times.
right. Yeah.
Mhm.
Yeah, great. Thank you.
Now we have a question from the YouTube. Um, do you think it's possible to create artificial nest sites similar to the roosts? I guess like the floating roosts for these birds. Of
Right.
course, artificial foraging habitat is going to be pretty tough.
Yeah, nest site. Of course, there's great examples in California of these with what is the bird's name in English? Rallies, rails.
Right.
So they
Mhm.
build this nest on the marshland. They are very, very vulnerable to inundation. These nests are designed to float as the water rises, and they have like this little shelter, and it has been hugely successful for these kind of birds. So yes, they are doing that, and I think you can even go and see them near San Diego in what they call the living coast facilities where they are recovering the rails. So yeah, definitely. For foraging grounds, that's I guess a different picture. And yeah, that's gonna be a tough one because it's as sea level rises, it's not only that the habitat is changing, the salinity is changing, the light level, the light that is, coming into the water is changing, the turbidity is changing, and the prey, they are moving to other places. So there's a shift on the whole system that we still need to yet understand.
Hmm. So tell us about rafts, and obviously you can't predict. So there's so many factors,
Hmm.
but tell us about the opportunity rafts may offer.
Yeah, so I honestly do not think that is a real solution for sea
Okay,
level rise
right.
because it's kind of tough to predict what's going to happen, and creating them at scale, it's probably complicated,
Right.
but taking inspiration on what birds are using does give us, solutions to other kinds of situations. For example, think about those urbanized environments where we have squished the land and we have left very little places to roost. You could put these rafts to create artificial roosts at those areas. We are seeing these in Korea. In Korea, they are doing a lot of land. They were doing a lot of land reclamation, leaving like
Mhm.
destroying the space where these birds could roost. And what they're doing is using oyster farms. And you can see the birds that they roost on the floating oyster farms. So that's again taking inspiration from nature, which I think is fantastic. And it's just
Yeah.
if you look and observe, they birds are telling you what they need.
Yeah. Yeah. Wow.
Maybe disturbance is another good example of how you could use these roosting areas. In areas where there's a lot of disturbance, maybe due to tourism, you could put these rafts at areas that are a little bit more deep. And the question then is whether the birds would like to use them or not. It's their choice, right? And they need to first find them and see that there's a reliable place that can be used.
Fantastic.
I have one more question. I was
Oh,
doing a snowy plover survey this weekend, and the beach that I was on, the grooming machines had come and basically removed all the rack, which of course happens because there's this tension between people who want to be on the beach and birds who want to be on the beach. I assume that many of the places that you've looked at, and certainly many of the places that are wetland friendly, that are mudflat friendly across this whole coast, are places where there is that interaction between people and these birds. And I wonder if like part of the recommendation maybe that we need to have based on your research that the rack can form these rafts, which is so important for the birds, that maybe another sort of adaptation to climate change effort should be to try to convince cities to leave areas where there is rack that can then turn around and make rafts.
I mean, I think in general, it's good to leave things as nature leaves them. But I must say that what we observed in Guerrero Negro, it's something unique. And we had the question, hey, is this only happening in Guerrero Negro? Why haven't other people observed this? So people have observed rack floating on the sea and birds using it. But this situation was different because this was dead rack, dead seagrass that like clumped together and floated dead, right? And I do believe that this phenomenon is exacerbated in Guerrero Negro due to the very unique geomorphology of the sea bottom that allows them to occur. But as I became conscious of this, I went to San Quintin and I went to other places. I saw the same rack, just not having the effect as pronounced as in Guerrero Negro. So I do think that the local conditions will dictate how effective these, rafts are working.
right.
I had a question too. I was wondering about uh, I think the 10 locations you had that were like the most important for red knots. I was just wondering about like the locations themselves. Are they like pretty well protected? Are they like reserves? Is there like permanent protections in place for like the lagoons that you had mentioned that were like really critical habitat areas?
The answer is yes, yes, some not. Uh, some not.
Some,
There you go.
Yeah. And it really depends, but in the case of red knot, I must say that I said that I started studying this bird very naively because I did not have a clue how difficult it would be to find them. And they tend to use very remote areas that are non-accessible with cars and stuff. So that's a good thing for them, not for me. And but in general, we are seeing the same pattern of what's happening in all coastal wetlands, like everywhere, more urbanization, more disturbance, more shrimp farms. So they are losing habitat. And the things that we do at Planatura is try to counteract those threats, like with direct conservation. So in some places it's getting better, some others not so much.
yeah.
Got you. Thank you. This was an amazing presentation. Easily one of our best ever, I would say.
Very
Thank
good.
Thank
you.
you.
That means a lot.
Yes, yes.
We have another question from Alexander Yan. Would artificial sand supplementation help with sand nesting bird habitat?
Oof. I mean, it's, the finding of the berm story to me was, hey, we should conserve the berms and we should replicate them. Like we should make higher berms for the birds. But when you try to supplement beaches with sand, then the questions that arise to me is, where is the sand coming from? What kind of sand is this? How are we knowing what the birds want and whether this sand has the invertebrates, like the food that these 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 birds are looking for? So there definitely needs to be a study when you do beach nourishment to try to replicate as best as you can the conditions that were original to the place. And most of the time when beach nourishment is made is not on the focus on the ecological aspects, it's focused on tourism and not losing the beach that you need to recreate.
Yeah,
Hmm.
But
very true.
I would say that in some cases it's better than nothing, putting the sand, but yeah, it would be on a case-to-case basis.
Great, thank you. Um,
Go ahead, Mark.
so Jim Zimmer was like as a comment. Documentary film school could supply a student committed to wildlife work over several years as part of a larger movie.
We accept volunteers.
Great. Anything else? I don't see anything. There are lots of thank yous in the chat. And let me add mine. Julian, this was a wonderful webinar. Thank you very much for presenting to us. Again, if you send Tori information on from your donation page, we can make sure it goes on to our webinar page regarding this. And again, thank you
Thank
very,
you.
very much.
Yeah,
Yeah, thank you so much.
I am pleased to have this invitation and look forward to more, and or maybe go to one of your events. It would be amazing.
Be
Fantastic.
great.
We have monthly webinars. Please join us for our monthly webinars. And speaking of monthly webinars, what do we have coming up next month, Tori?
We are looking at, hold on just one second, because I don't have this up and I haven't looked at it a couple days. Yeah, you caught me off guard there, Ron. Hold
I
on.
know.
Ron loves to do that.
Intentionally, huh? All
Mhm.
right, hold on. Give me one second. All right, our next one is going to be on the Genoscape project, looking at evolutionary distinct lineages of birds of prey, migratory birds of prey, and how they have diverged as a response to climate change. It's also looking at climate change and bird evolution.
Fantastic. So that's on the second Tuesday of next month. Please join us. And Julian, you have an invitation to join us. And half our webinars are more scientifically based, and half are, give or take, about half are more identification based. So if you go to our website, we have a listing of all our webinars for you and for everyone else, that divided up between those areas, and it's fantastic. And with that, thank you all for joining us. We really appreciate it. And once again, Dr. Julian Garcia Walther, thank you very, very much for presenting.
Thank you so
And
much.
Yes, thank you. This is
Thank
amazing.
you. Thank you.
Thank you, Julian. We loved it. Thank
Very,
you.
very good presentation.
and we'll see you all next month. Take care, everyone. Bye-bye now.
Goodbye.
Bye-bye.